Right. Today's lesson, we're going to look at limiting reagents. Now, the word reagent essentially means reactant. So a limiting reactant is one which will ultimately affect how much product you can actually form. So theoretically, you could have two reactants that are in perfect proportion to each other. Then there will be no limiting reactant, no excess. However, you can also get a situation where you have one reactant which is in excess, there's too much of it, and one which is limited. So let's have a look. This is all about reacting ratios. We have a 1:1:1 ratio. So therefore, if 2 moles of calcium oxide reacts with 3 moles of water, the smaller number would be the limiting reactant because it's simply smaller than this one, and the ratio is 1:1. To determine how much product you can actually form, always look at the ratio between the limiting reactant and the product. So it's 1:1. So if we have 2 moles here, we have 2 moles here. Another example, we have 10 versus 8 moles. So 8 is limiting, and the product will also be 8 because it's a 1:1 ratio. And here 0.4 will be limiting, and the product will be 0.4. Now, what happens if the ratio is not 1:1? We have a ratio of 2:1 here. So if 2 moles of calcium reacts, it should only react with 1 mole of oxygen. However, oxygen seems to be 2 moles. That means there is too much oxygen, making this the limiting reactant. So I went from left to right when I looked at this. You could also look at it from right to left. So we have 1 to 2. So 2 should go to 4. However, this is only 2. So this is the limiting reactant. Now the product has a ratio, so 2 to 2, so 2 goes to 2. That's how much product you can get. Let's look at the next one. We have 10 moles of this, but the ratio is 2:1. So 10 moles needs 5 moles to react, but 2 is smaller than 5. So that means there is not enough oxygen, making this the limiting reactant. Then the ratio is 1 to 2, so 2 goes to 4. So you see, you can't just blindly pick the smaller number. That would be wrong. Okay. Sometimes you have 2 of the same number and so on. Let's have a look at this one. We have a ratio of 2 to 3, which is one of the ratios people find harder. So if 2 goes to 3, then 3 moles should go to what? So imagine you don't actually know this number. So if 2 goes to 3, it has been multiplied by 1.5. So 3 needs to go to 4.5. But 4.5 is bigger than 3, which means 3 is not enough, making this the limiting reactant. You can also go right to left if you prefer. So 3 goes to 2. So 3 needs to go to 2. But 3 is bigger than 2, so there's too much of it, making this the excess. And by default, the other one's the limiting one. Now the product, we have 3 to 2, so 3 goes to 2. 2 moles of product. I'll do one more example. For these 3C, we have a ratio of 2 to 3. So 20 should go to 30, but this is 40. 40 is bigger than 30, making chlorine an excess. That makes this the limiting reactant. The ratio is 2 to 2, so 20 moles will form 20 moles of product. And that's how you do it. I always go left to right. If you go right to left, you could say 3 goes to 2, so 40 should go to whatever 40 divided by 1.5 is, which will be around 8, about 20 point something, so it'll be over 20. So it'll be bigger than this, making this the limiting. Okay, I'll show you one more scenario where we have 2 products, and then we'll go on to the main course, because these are just the build-up. This is how you find the limiting reactant. That would normally be worth kind of 2 marks. Finding the actual product is the objective. Let's look at 4A as our final example. We have a ratio of 1 to 4. So 4 should go to 16, because 1 times 4 is 4. So 4 times 4 should be 16, but 4 is much smaller than 16, making this limiting. Now, to determine the products, we always use the limiting one, remember? So we ignore this, and we look at the sodium. The sodium has a ratio of 4 to 1, so 4 goes to 1. And then 4 goes to 4, so 4 goes to 4. And that's the moles of products that you will form. I suggest you try out this worksheet and work through the problems to make sure you understand the limiting reagents. Then you move on to limiting reagents 2 worksheet, which is more like what the exam will be like. So let me close this and load up the next sheet, which is limiting reagents 2. This is more like what you would get in an exam scenario. Now, I'm not going to go through numbers 1, 2, and 3 because all the ratios are 1 to 1. So that makes them easy, okay, technically. I'm going to straight away show you one where the ratio is not 1 to 1. But I suggest you go back and do the original ones. There'll be full solutions anyway, provided for you like this. So you will have the full solutions. In fact, for number 1, I might just use the solution to go over it. So let's have a look. We have 10 grams of calcium oxide reacting with 10 grams of water. What mass of calcium hydroxide is formed? The first step, just like in all of chemistry, is to find the moles. So I do mass over MR. So for calcium oxide, it will be 40 plus 16, which is 56, as the MR. So 10 over 56 gives you this. And for water, it'll be 10 over 18. Remember, water adds up to 18, and that gives you the moles of water. Now, because the ratio is 1 to 1, you simply pick the smaller number. So that means this must be the limiting reactant. The calcium oxide is limiting. So then, if you have 0.17 grams moles of this, you will have 0.179 moles of this because they're in a 1 to 1 proportion. In the final step, you use the mass formula. So mass is moles times MR. So the MR, importantly, of this product will be 16 plus 1, which is 17, times 2 is 34, plus 40 is 74. So that's the MR. And the moles we just deduced was 0.179. So when you multiply them, you get 13.2. So that was technically an easy example. Let's look at something like number 4. Okay. So number 4, we have sodium, 2.3, chlorine, 2.85. And we're looking for the mass of sodium fluoride. Step 1 is moles. So for sodium, we do 2.3 over 23. If you look it up, it is 23, and you get 0.1. But then for the other one, you need to do F2, which is 2.85 over 19 times 2 is 38. Remember, little numbers are the only ones that count when you do AR or MR. That will give you an answer of 0.075. Now, you cannot just pick the smaller one, okay? You must look at the ratio. So the ratio is 2 to 1. So therefore, 0.1 divided by 2 will give you 0.05. So what I've done here is I know this one is 0.1. The ratio is 2 to 1. So I must divide by 0.1 by 2 to get 0.05 moles of F2 needed. That's how much you need to react with the sodium. However, this number is bigger than this number. So it must be an excess. Therefore, sodium is limiting reactant. You see that logic? Because the fluorine was too much, we only did 0.05. The fluorine was in excess, making the sodium limiting. Now, the ratio between this and this is 2 to 2, which is basically 1 to 1. Therefore, whatever the moles of sodium was, the 0.1, will be the same as the moles of sodium fluoride. So 0.1 moles of NaF. Then what you do is plug into the mass formula, which is moles times MR. So 0.1 times the MR of this one. Again, don't count the big number. That's part of the ratio step. So 23 plus 19 is 42, which will give you an answer of 4.2 grams. Now, this full solution is in full written in the answers, so I do not need to screenshot this. You can have a look at it in the answer sheet attached. And I suggest you work through all these problems because this is probably harder. This is harder than reacting masses and harder than percentage yield. Okay, so this is one of the harder parts of the calculations. Having done limiting reactants, there's one other small thing we need to do, which is called finding reactant ratios. Finding reactant ratios from actual equations is what we need to do. And I'm going to show it to you directly using the answers. I will go over kind of 2 examples. So maybe 3 examples. We'll go over 1 and 2, and then 1 from the longer questions at the back. So 140 grams of nitrogen reacts with 30 grams of hydrogen. Write down the molar ratio of the substances then react. So you can often be asked to work out the actual equation from these. What you do, just like in all of chemistry, is find the moles first, mass over mR. So the moles of N2 will be 140 over 14 times 2, which gives you 5 moles. Hydrogen will be 30 divided by 2, because it's 2 times 1. Mass over mR, or over AR, since they're elements, gives you 15. Now, this time, we don't know the actual equation. So what we do is we find the simplest whole number ratio. To do that, we divide by the smaller of the 2 numbers. So 5 divided by 5 gives you 1, and 15 divided by 5 gives you 3. So you get a ratio of 1 to 3. So then you just write N2. There's no point to put a 1 in front, just like we don't put 1x in maths. Plus, there's 3 of them, so we write 3H2. And that's all there is to it. If you look at a second example, this reacts with this. Once again, mass over mR. So 5.8 over the mR of this. 12 times 4 plus 10 times 1, 58. You get 0.1. Oxygen is 16. So 16 times 2 is 32. Mass over mR, or AR, gives you 0.65. Then remember, divide by the smaller number. So that divided by itself is 1. And this one divided by 0.1 is 6.5. Now, something interesting has happened. You've gotten a 0.5. Do not round it. If you get a 0.5, you double everything. Because we want the simplest whole number ratio, not decimal. So 1 times 2 gives you 2. 6.5 times 2 gives you 13. So when you write out the equation, we have 2 moles of the butane, so it's 2 in front. And we have 13 of the oxygen, so we write 13O2. And it's not very difficult at all. So divide by the mR to find moles, divide by the smaller number. If you get a 0.5 or something like a 0.3, you might need to double or triple it. Let's look at one final example, number 5. So number 5. I'm going to cover up the bottom bits. We don't need that. So concentrate here. Make it a bit bigger. Okay, so ignore the bottom bit, I'm just covering up. Let's look at this. This time they give us all the chemicals in the equation, so we have to write the full equation. So we have 0.92 grams of this, decomposes, which means arrow, 0.773 of this, and this much carbon dioxide. Step 1, moles equals mass over mR. So divide each by the mR. I'm not going to talk through each individual one, you have to use the periodic table. This one will be 276, so you divide them. This one will be 232, divide them. Carbon dioxide is 44, 16 times 2 plus 12. So divide it. And you actually end up with the same number each time. So the simplest whole number ratio obviously is 1 to 1 to 1. You divide everything by the smallest number, in this case, the number, and you get 1 to 1 to 1. So when you write out the equation, it's 1, 1, and 1. You don't have to put any numbers. Okay? So practice this. This is like a very small section of the syllabus. It's not often tested, but it has come up on papers. So do take care. Okay. Join me next time for gas volumes. That's the end of this lesson.